Test, 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 test. Test, test, test.
Test, 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 test. Hello everyone and good afternoon here from COP27 Sharm el-Sheikh. My name is Christoph Henrich and I have the honor to moderate this concluding first week side event of the IAEA at its Atoms for Climate Pavilion, focusing on climate change impact in mountains, how the melting cryosphere affects local communities and ecosystems. When I moved here in 1974 with my family, the glacier came down as far as there, and the ice was blue. Everything has changed. Now we have lots of caterpillars of a kind I've never seen before. My llamas swallow them and it makes them sick. Guillermo Aroquipa, a 73-year-old farmer from Bolivia. I spend 3 to 4 hours a day fetching water and my neighbors do the same. I'm experiencing body pain and backache as a result of water fetching workload. Amia Parua from Nepal. There's less water now. 7 of my 8 children have left the region because there is no way for them to make a living. Most of the men of the village have also gone, heading to the conjoined urban sprawl of nearby La Paz en el Alto in search of work, returning just once or twice a month to see their wives and families. De Cuida Quispe, a 60-year-old mother, grandmother, and farmer. Between 1980 and 2010, 25% of glacier area decreased in Nepal. At least 1/3 of the glaciers in the Hindu-Kush Himalaya region will be gone by 2100. This will have a serious implications for downstream water availability and dependent sectors. Isimot. As these quotes show, climate change in mountain regions is already a reality. It has a severe impact on the local biodiversity, on the ecosystems, the communities and the farmers living in these areas. Globally, an estimated 1 billion people are living in mountainous regions. And these are not the only people affected by climate change. Several billion more are actually dependent on the water resources or natural resources as a whole that are provided by mountains. And these resources, such as water, for example, flowing downstream, being used for industry, agriculture, or energy generation. And what does nuclear and isotopic techniques have to do with this? Well, these techniques can be used as a very effective and precise tool to assess the impacts of climate change in mountainous regions and can answer questions like, what is happening with my wetlands? What is the impact of the wetlands if the glacier is retreating? Or analyzing the sediments that are released from glacier retreat and see whether they have an impact or pose a potential risk for glacier lakes, such as glacier outbursts, floods from these retreating glaciers? These questions we're looking in an interregional project on assessing the impact of climate change in the International Atomic Energy Agency, and we're working mainly with two mountain regions, which is the Himalaya and the Andes. And I'm very glad to have two of the dear counterparts from these projects here. Can we have the introduction slide back? Thank you. First of all, Mr. Binod Heyuyu from Tribhuvan University, Pokhara in Nepal, and Mr. Edson Bramimes from University of San Andres in Bolivia. Of course, we want to ensure that this scientific evidence that we are generating by these projects is being picked up by policymakers. And hence, I'm very, very glad to have Ms. Satnam Shivakoti here, who is a joint secretary of the Ministry of Agriculture in the government of Nepal. And last but not least, we are not doing this project alone. We're working with our friends and partners from the international community, because it is utmost important that we work as many stakeholders as possible to transfer this scientific evidence into effective policy. And hence, I'm very glad to also welcome here Ms. Diane Kopansky, who is a Program Management Officer at the United Nations Environment Program. We are now, will be listening to three presentations, first by Binod, followed by Edson, and then Diana, and then I'm glad to have a panel discussion to discuss a few questions afterwards. So, having said this, I hand over to Binod, who will go to the podium to present. Thank you.
Thank you very much, Christoph. Distinguished participants, panelists, having set the scene about the whole story, what we are going to talk today, let me start with my own story. As you can see in the slides, that isn't this amazing? What you can see is that's the office where I work, and moreover I would like to show you the backdrop, which is the Annapurna Himalaya range. And this is this spectacular scene which we can see from our doorsteps. That is the partly the reason why I could not leave my job. And beside that, being a professional from the civil engineering background, while I joined the Forestry Institute, and I came to know that forest basically is a potential for the mitigation of the climate change. That's another reason why I would like to continue as a faculty in a Forestry Institute. And Pokhara being one of the top 10 actually tourist destinations in the world, and the Annapurna Trek, which has been listed by the Lonely Planet as one of the top 10 trekking destinations. So we can imagine, but as I said, the mountains is not only for the recreational area and the tourism. Beside that, it has sorry. Oh. Thank you. First slide, please. Yeah. And as I said, beside the tourism activities as well as the recreational, it has a lot of to do actually, mountains. And you know, mountains globally is the home for about a billion peoples, and they do provide wide range of the ecosystem service and the products. So as you can see in the slides, there we can see a number of goods and the ecosystem services that provide. So in brief, if I just point in kind of biodiversity, it's hosts around 25% of the biodiversity of the land. And in terms of the forest, it was about the 28%. And when we see the crops, 6 out of the 20 important crops, they are grown in a mountain area. So this is what shows how significant is the mountains. And in particular, next, when we talk about the water services from the mountains, it's phenomenal. Like about half of the world's populations, they depend upon the water from the mountains for their kind of the drinking, irrigation project, industry project, and the energy sectors. So, and when we see the irrigations, I mean the mountain is the one that supplies 40% of the water worldwide to the irrigation sectors. And globally, when we see, like in Latin America, the hydropower is the one which accounts 85% that produces the energy. And similarly in Africa, East Africa, in Kenya as well, like 7 million people, they depends upon the fresh water from the Kenya mountain. So this really highlights globally as well how significant is the mountains in terms of the water resources as well. And when we come to the Hindu Kush Himalayan region where I belong to, it's incredible. If you see there, like the Hindu Kush Himalayan, we call it as a third pole of the planet or of the earth as well. So that means it holds the massive amount of the water in the form of the ice and snow. And in a way, it is also called as the water tower of the Asia because, I mean, it supplies the water nearly to the 3 billion people through its 10 major river systems. So this is how, if something goes wrong in the Himalaya region, then we can, imagine that the catastrophic. And unfortunately, this is what's happening because of the climate change. So, and I mean, due to the climate change, we have been observing a scientific study that shows that there have been quite a lot of changes in terms of the retreating of this snow in the mountains. And it's not the only science says, but the local people have also clearly observed things. And this is a video that I'm going to show, which was prepared by our student and the students from the University of George Mason's, which is purely educational materials. But in this material, the Tendi Sherpa, who is a Everest climber, as well as he is a trainer, expedition leader, and he has also witnessed. Let us hear him, what he says.
Every year, because it changed so much. Just from day to the day, it changed a lot. Some of the place, the glacier went back 200 meters. In 20 years, you can imagine, 200 meters. And the glacier were, during 97, 98, those glacier was like 80 meters deep, but now they are down to 30, 35.
So, as I said, I mean, this is what happening not only in Nepal, but if you see along the Hindu Kush Himalayan range, and this kind of changes rather decrease in the snow caps and the ices that we can observe. This is one of the pictures that I'm showing you from the north and east of the Mount Everest, which clearly shows over the period of the 80 years the changes. So, I mean, these kind of things really will be detrimental to the whole planet, as we have already come to know that the billions of people, their livelihood, the ecosystem services that has been provided, they all will be jeopardized. So, that's why, I mean, we have to really think about the seriousness of the impacts. And when we see the impacts, well, as I said, along the Hindu Kush River only, so it's around 3 billion people. There will be shortage of the water. And the water crisis issue has been emerging a lot, actually, when we see, particularly in the Hindu Kush Himalayan as well, and not only in Himalayan, but in other mountainous area, say for the Andes, say for the Alps. This is what is happening. So this kind of the crisis in Nepal too, I mean, we have many examples whereby there has been, we have to relocate the village from one place to another place. And I would like to show you again another video clips where a country representative, Dr. Ghana Gurung, he is the WWF country representative, and he is also from the Himalayan region. And he can say from his own experience and as a professional on this background. So please, I would like to request to play the video.
This is Dr. Ghana Gurung, the Nepal country representative for the World Wildlife Fund. Dr. Gurung grew up in the high mountains of Nepal.
Mustang region is a beautiful place, a nice landscape, where most of people from Nepal see mountains to the north, where we see mountains to the south. People begin to see groundwater source is not anymore a source. And many cities are actually getting dried up, and water tables getting dropped and dropped and dropped. Water is not recharging anymore. Nepal, many villages are running out of water, and that's why some of the places in my Mustang, where few villages have need to be relocated, they are actually displaced because they are running out of water, and that's the beginning of the impact being felt by ordinary people, farmers, livestock herders.
So, I mean, given this scenario, now we all have to collectively respond how we're gonna deal with this kind of the problem. And as from the academic field, I mean, I prioritize to the research. As the new tools and technologies are emerging, so, I mean, which can add the value, not only in terms of the cost, but in terms of the efficiency, effectiveness as well. And here, we have to really employ these kind of the instrumentations, because we have to treat mountain as a pulse of the planet. We cannot, of course, neglect it. So here, this project, as Christoph mentions before, now we are trying our best to understand the climate impact by installing a very well sophisticated neuron sensors, cosmic CRNS, cosmic ray neutron sensors, which will basically be one step ahead, and that will enable us to do quite a good research. And here, as we are talking about the installations of this kind of the good instrumentations, and we have to have a good collaborations among all of us, be that the government, be that the academic institution, be that the local stakeholders, and that's what we are aiming. And as per our plan, the sensors will be set up something in a March or April, and we will have a kind of the meetings among our stakeholders for effective operations of that machine. And luckily, the instrument has already been used in my fellow's country in Bolivia, and I hope my friend will explain about its applicability, and that will help at least to us acknowledge this kind of the instrumentations. With this, I would like to stop my remarks. Thank you very much.
Thank you so much, dear Binod, for giving us this shocking, yeah, very important and insightful overview how the situation looks in the Himalaya and what are the plans that you're having under this project. And now I'm very excited to announce Edson as the next speaker, because as Binod has said, Edson has something to present on that device that Binod had mentioned, because he has installed it already a year ago. Edson, the floor is yours.
Thank you very much, Christoph. I want to thank to IAEA to give us this opportunity to present our interregional project and the first results of our project. This is a nice picture that we have with our new device. This is the cosmic ray neutron sensor, and this is the place where we're working now. So the Bolivian Altiplano, it's located at 3,500 meters above the sea level and comprise around 1/3 of the Bolivian land area. It's located within the Andes and enclosed by two mountain ranges and adjacent to the cities of La Paz and El Alto. This is the Cordillera de los Andes. It's an extensive mountain range that it's about approximately 120 kilometers, with the snow-capped peaks can exceed even 6,000 meters above the sea level. So this is the Himalaya, the Huayna Potosí mountain, with a peak with an altitude of 6,000 meters, and it contributes with meltwater along with rainfall to supply water for Tuni Dam, and it's an old glacier lake. And in the right side toward the Amazon basin, its water also used for generation for hydropower. This is the city of El Alto and city of La Paz, and in this case the Tuni Dam, with a capacity of around 26 million cubic meters, supplies water for human consumption to the city of El Alto. It's located at 4,000 meters, and part of the city of La Paz located at 3,600 meters. And one important thing is that about 1/4 of the Bolivian population is concentrated in those cities. But however, at the lower part of the snow-capped Huayna Potosí mountain, there are also small communities that use the waters from the glaciers and extensive wetlands for their productive activities. In the case of Tuni village, this is the picture. Tuni village is located at 4,400 meters above this level, bases its economy on rising camelids and growing potatoes in a small scale. Above the Tuni village, in the bottom part of the glacier, there are still a group of families that are settled in this place. They are exposed to more extreme weather and have used glaciers and wetlands for a long time. This is my friend Guillermo. He's Guillermo Aruquipa. He's an 80 years old resident who was born in this place and has seen with great concern how the climate changed over the time his environment. And Guillermo, with great concern, showed us the current state of the glacier, and he told me some stories related his grandparents, and he said to me that in this period the ice even reached the place where he is standing. Local inhabitants in high mountains have seen the glacier retreat drastically in the last decades. This is the case, for example, the glacier Chacaltaya in the upper part. So we can see how the glacier disappeared. Or the case of Ullacaya Glacier in the bottom part, where you can see on the right side there is a small circle where it's my colleague where surveying the front of the glacier, and we can see the difference how the glacier retreated in the last decades. So Guillermo longs to be able to better understand what's happening with climate and how he could prepare to face these impacts that affect his quality of life. With Cryo, he asked scientists, he asked the academic sector for help, hoping to have some tools that will help him to detect, for example, extreme events, that means floods, droughts, or frosts. However, the challenge is complex because the relationship between the Andean glaciers and wetlands has not yet been fully studied in this altitude. Those are some pictures of a previous project conducted also with the International Atomic Energy Agency. And the previous used conventional methods, applying isotopes, for example, and other techniques, have already reached their limits of applicability, and more precise and less labor-intensive methods are needed now. And thanks to a joint effort between the local sciences and the technicians together with our colleagues, experts of the International Atomic Energy Agency, in December 21, the first cosmic ray neutron sensor in the Andean region was installed at an altitude of 4,500 meters above sea level. And this novel instrument will make it possible to accurately quantify the moisture content of the soil in wetlands and landscape scale with a representativeness about 30 hectares. So now Guillermo is finally happy to see the equipment already assembled, but also my colleague Fabiana, who is a Bolivian engineer from the Ministry of Environment and Water, and even for my colleague Trenton Franz, the expert of the International Atomic Energy Agency, it was also a new experience to work at this altitude and this very particular ecosystem. Yeah. And now in this picture, the great day has arrived. The equipment is working, and it's transmitting with its satellite antenna to a data reception center. Guillermo he's very proud to have this important device located very close to his home, and he's sure that with this new information he will be able to complement his local knowledge and better adapt to impacts to climate change. Yeah, but it's not only Guillermo and the residents of the Tuni village who will benefit of this information, but also the inhabitants of cities of La Paz and El Alto will also benefit because this instrument will be part of a more ambitious project that is the development of an early warning system that will help to detect and characterize the arrival of extreme events in this region. And after about a year of an observation, the results are very promising. A comparison made between the moisture content of the soils at the foot of the Huayna Potosí mountain and the rainfall measured at a meteorological station located 24 kilometers from this point, compared with a weather station located at the airport. As you can see in this figure, there is a clear correspondence and representativeness between the moisture content in the soil and precipitation. And the vast experience of experts from the International Atomic Energy Agency has also allowed to develop a virtual platform to quantify the soil moisture content in the entire area, considering all the catchments, because the cosmic neutron sensor data will make it possible to calibrate data from satellite Sentinel-1, with which the monitoring coverage area can be extended. And these efforts currently provide two very valuable tools for real-time monitoring of soil moisture content in the study area. And there is a real-time reception of the cosmic neutron sensor measurements, and on the other hand, there is a virtual platform based on the data from Sentinel-1 satellite. Soon we will be able to real-time soil moisture measurements. We will be able to obtain these measurements in this site. This is the Tune village, and we will use a Bolivian communication satellite. The name is Super Qatar, and as part of the early warning system at the community level. And Guillermo and the residents of the Tune village will have also two satellite antennas to receive this information in order to complement the early warning systems. So these devices will allow them to have internet connectivity to obtain all the information. And finally, we think that the more important thing, the main objective is not necessary to understand what is the characteristics of the scientific basis of the technologies that we are using, as the case, for example, the cosmic neutron sensor. But the most important thing is how can we use the results of these devices to provide more information to local residents, and how can we adapt face to the impacts to climate change. And to this I want to thank you, and we are very excited and motivated to learn more about how can we translate the science into policies, the importance of partnerships. And let me introduce please colleague Diana Copan. Thank you very much.
Thank you very much. Thank you. Thank you very much, dear Edson. First of all, I want to congratulate you on the work that you have achieved so far on that project. But second of all, I could not have done a better transition to hand over to the next speaker, Diana, who will now give us an overview on what UNEP is doing in the area of climate adaptation, and exactly how you said it, the importance to translate this data into policy. Diana, the floor is yours. Thank you.
Thanks, everyone. I need my computer for my notes. My name's Diana Kopansky, and I work for the United Nations Environment Program, and I'm really happy to be able to share some of the incredible work that my colleagues in our mountains team have been working on. Mountain ecosystems are by nature transboundary, and the impacts of climate change are also felt regionally. For example, you can see here the high Tatras of the Carpathian Mountains, which run through Poland and Slovakia. Climate change has led to much higher temperatures, Temperature changes in the tree types are showing this. You can see some dead spruce trees here. Not sure what the okay. Thanks. And of course, this is giving challenges for the people that live in this area, but also affecting tourism, especially ski season in the winter. We know that as well that Lake Titicaca is closer. Sorry. We know that the Lake Titicaca is also suffering from higher temperatures, changes in precipitation, and loss of water volume. This is obviously going to be affecting people's livelihoods and the health of the ecosystems upon which we depend. And at UNEP, together with the collaboration of the government, we work with academia, civil society organizations to try to find regional solutions to abate climate change, to support climate change adaptation and mitigation measures in the mountains. This can include data sharing, as we're seeing here, also working with expert visits and transfers, as well as helping to define modes, methods, and guidelines for restoration techniques. The challenges are regional in nature, but they also need to be solved by many. So I wanted to just emphasize this transboundary element of working across mountains. UNEP's work on tackling the climate crisis in mountains focuses on, first of all, strengthening resilience and adaptive capacity by working across and with many partners. We're also supporting the national adaptation plans and adaptation policy processes and fostering these important science policy platforms for regional as well as global exchanges to happen, where science is available to inform the best possible outcome for decisions. And you may have heard it, we're working on the adaptation at altitude. It's a collaborative global program. It's funded by the Swiss Agency for Development and Cooperation. And its main objective is to increase the resilience and adaptive capacity of mountain communities and the ecosystem upon which we depend to climate change. And we're doing that by gathering data, information, and knowledge on effective climate change adaptation. We're also facilitating evidence-based decision-making for strengthening mountain adaptation in national, also regional, and global policy processes. And this program has 4 components. In data, and we're doing informing and monitoring. We aim to improve the availability and the use of mountain observation data and information services. In the regional exchange and collaboration area, we facilitate science policy dialogues in 4 mountain regions and have supported inter-regional collaboration and sharing of experience. In the area of knowledge and sharing, we support community of practice on climate change adaptation in mountains, and we have a global database on adaptation solutions, especially for mountain regions. And in the global policy mainstreaming, we foster global advocacy for inclusion of mountain adaptation relevance in policy processes, from the UNFCCC, where we're here today, to the Sendai Framework for Disaster Risk Reduction. We're also working on the Convention of Biological Diversity and supporting the upcoming Global Biodiversity Framework and the Sustainable Development Goals. Mountain targets, mountain-specific